Okay, so we're working with direct variation. Uh, Direct variation is when the ratio of corresponding values is a constant, i.e., if you get paid by the hour, the more hours you work, the more money you make. You work more hours, you make more money. And it's a corresponding relationship. Okay? The constant of variation is what the ratio of those two objects are. In other words, how much you get paid per hour. Okay? That would be your constant of variation. If you get paid 40 bucks for 2 hours and you get 80 bucks for 4 hours, you're getting paid 20 bucks an hour. That's the constant of variation. It's the relationship between them. Okay, does that make sense? We are going to work with, you'll notice I wrote over on the sideboard basic things that I'm going to need to remember while we're working through the rest of these problems here today. Is that for it to be direct variation, it needs to look like this. Y equals kx, where k is a constant value, or my constant value is equal to y over x. Both of those are different forms of direct variation. Okay? And if I have direct variation and I have two variables that vary directly, those two variables will have the same relationship every single time. Y divided by x equals y divided by x equals y divided by x equals y divided by x every single time, no matter what, if it's direct variation. We will expand our direct variation near the end of second semester. We will revisit this then, and we will expand our variation to include indirect variation and other kinds of variation as well. We're just going to talk about direct variation here today, though, but we will revisit this in more detail at the end of the second semester. Any questions so far? It's fairly straightforward. Okay. So, example number 1, write each variation. X varies directly as Z. That means that I have X divided by Z. That is my variation. And that is equal to some constant value. I don't know what that constant value is, but I know it's equal to some constant value. That is my variation. It's always the first one divided by the second one. Now, this is a problem I can solve. B varies directly as A. That means I have B divided by A. It's always B divided by A. It's always B divided by A. There we go. Just to give myself a little more room. So, if B equals 12 when A equals 8, so that means I have 12 over 8, B over A is B over A, B over A, B over A. Find B when A is 6. Set up the relationship. 12 over 8 equals B over 6. B over A, B over A, B over A. Plug in the two things that are related, the one you're looking for, and the one it's related to. Now, proportions. All kinds of ways to solve proportions. I don't care as long as you get it correct. If I look at this one, I know what I'm going to do right off the bat. Well, and then there are a few things you can do. These numbers aren't large, but one thing that would make it easier is if I reduce any fractions, I can reduce. 12 over 8. Divide them both by 4. So that means B over 6 is equal to 3 over 2. Right? 12 over 8 reduces to 3 over 2. Smaller numbers are easier to work with, are they not? Less likely to have an error with smaller numbers. Once again, from here, several ways I can do this. I really don't care as long as you're getting the correct answer when you do it. Now, I have a variable divided by a number. The easiest way to do that is multiply both sides by 6. So I get B equals, do my multiplication, 2 reduces, and I get 9. Or B over 6 equals 3 over 2. Well, what do I multiply 2 by to get 6? 3. So I times 3, so I do times 3. So B equals 3 times 3, B equals 9. That's figuring out the problem, seeing the relationship between them. If I can do that, that's an easy way to do it. It's proportional. And then last but not least, there is one way to solve every single proportion, no matter what it is. Every single proportion can always be solved. B over 6 is equal to 3 over 2. Every single proportion, no matter what, can be solved by cross multiplication. B times 2, 2B, 6 times 3 equals 18. Cross multiply, it will always be equal. No more fractions. Easy to solve from here. Divide both sides by 2. And look, I get B equals 9. I get B equals 9, B equals 9, B equals 9. Does not matter the method I choose. I can choose any method I want. Cross multiplication will always work. But it's not always the easiest way. I look at this, I'm going 2 to 6, oh, that's easy. Do the same thing to the numerators. Here, oh, I don't have to just multiply by the denominator, get rid of the denominator, I'm good. The one time I'm guaranteed to do cross multiplication is if I have the variable in the denominator and it's ugly. Ugly numbers. I'll do cross multiplication. Now, the next one's a little more complicated. You have to be careful. What am I comparing? M and N squared, not N squared. Okay? So if M is 12 when N is 3, so M is 12 when N is 3, so I have 12 over 3 squared, not 12 over 3, 12 over 3 squared. Find N when M is 24. It says M varies directly with N squared. Not M with N, M with N squared. So if I'm solving for N, I still have to remember I'm doing N squared. And now I can solve it. There's lots of ways I can do this one as well. I go ahead and square out the 3 just to make sure 12 over 9 is equal to 24 over N squared. Okay. Several ways I can do this. I can cross multiply, I can reduce. I look at this one and I go, wait a minute. Right off the bat, 12 to 24. What do I do to 12 to get 24? Multiply by 2. So what am I going to do to 9 to get N squared? I'm going to multiply by 2. So if I take 2 times 9, that's what N squared is. So N squared is equal to 18. 12 over 9, 24 over 18. Makes sense. It's proportional. Now, to get N, square root both sides, N equals the square root of 18. And as far as I'm concerned right now, that is good enough for me for an answer. Although technically, it should be 3 root 2. But I'm not going to worry about that. If you gave me the square root of 18, I would be fine with that. Okay? Your turn. And watch the second one. Okay, so the first one, H varies directly as K, so I have H over K. So if H is 15 when K is 5, find H when K is 12. So 15 over 5 reduces to 3. So I have 3 is equal to k over 12. Multiply both sides by 12, and I get k equals 36. If you figured out that, oh, it's equal to 3, it's going to be 3 times as much, it's 36, that's fine with me. Once again, there's lots of ways to do that. That's the easy way for me. Second one, c varies directly as the square root of d. C, square root of d. Very important. So I get when c is 18 when d is 25, so 18 over the square root of 25 equals, I don't know, over the square root of 36. Set up first, then solve. So 18 over square root of 25 is 18 over 5 is equal to c over 6. I would multiply both sides by 6. Those cancel. I get c equals 6 times 18. 6 times 10 is 60. 6 times 8 is 48, so that's 108 over 5. Yes? If you cross multiply, you'd still get the same thing.
No, what I'm saying is like the 6 and the 18.
It would not reduce when you cross multiply.
Wow.
Because they're not over each other. There's an equal sign in between. You're not multiplying them, you're cross multiplying. Other questions? Okay. Determine if the following are direct variation, and if so, state the constant of variation. In order for it to be direct variation, y over x must equal the same number. When I take y divided by x, I get the same number every time. 2 divided by 1, that's 2. 6 divided by 3 is 2. Is it direct variation? I don't know. Got to check them all. 8 divided by 4 is 2. Yes, it is. And my constant variation is 2. You have to check all of them. Okay. On this one, same idea. Y divided by x. Y divided by x. It's 4. It's 4. It's 3. It's not direct variation. Because it has to be the same one every single time. No exceptions. If you have an equation and you want to know whether it's direct variation, here's the thing. It has to look like one of these two. It has to look like one of these two in some form or another. Where k is some value, some numerical value. Does the first one look like either one of these? Yeah, it looks like the first one. So the first one is. It's a big yes. The second one. Does it look like one of those two? No. There's no addition or subtraction in direct variation. Next one, yes or no? Yes. And what's my constant of variation in this one? My k is what? K equals -5. K in this one is 2/3. Pretty easy, right? Your turn. Okay, so on the first one, you need to check y divided by x. 2/3 divided by 2. So if I have 2/3 and we split it into half, how many parts are there? So if there are 2/3 of the pizza and I eat a third, she eats a third, how much of the pizza do each of us eat? 1/3. 2/3 divided by 2 is 1/3. So I get 1/3. 1 divided by 3, that's easy. 5/3 divided by 5 is 1/3. So this is direct variation, and K is 1/3. The second one is its direct variation. Yes? No? Maybe? No, it's not, because I got the addition in there. Addition just tosses it right out. This is a nope. The last one, is it direct variation? Does it look like one of these? Can I make it look like one of these? Yeah, if I can make it look like one of these, it is direct variation. To find out what K is, divide both sides by 7. Negative 2/7 x is equal to y. So my K is negative 2/7. So yes, it is. And then I love direct variation word problems because they are the easiest word problems. They are the easiest way. What are the two items, not numbers, what are the two items I am comparing? Grams and calories. Grams and calories. And it doesn't matter which one I put which. Grams and calories. There's my relationship. Plug in the numbers appropriately. 50 grams, 200 calories. 50 over 200 equals 70 grams over how many calories? Okay. First thing I would do is 50 over 200 reduces. And then that makes it easy. The number of calories has to be 4 times the number of grams. Yeah. So the number of calories is 280. That's a lot of calories. The nice thing is, if you eat the right kind of cheese, you get no carbs. The harder the cheese, the fewer carbohydrates. The softer the cheese, the more carbohydrates. Read the nutritional labels.
What about brie, where it's kind of hard?
Brie is soft. It's considered soft cheese. It has still has a lot of the lactose in it. Or not lactose.